For many hardware components, we will need to add a resistor to reduce the current which goes through a component. Basically, for a same applied voltage, the higher the resistor, the lower the current. For example, if we just plug an LED like that to an Arduino pin, the LED might be damaged or destroyed because it can't handle too much current. So we will add a resistor. For this course, you will only need 220 ohm and 10 kilo ohm or 10,000 ohm resistors. I won't go into much details about the computation for those values, but they are pretty standard though and can be easily found on the internet. Whenever you need to connect a component to your Arduino, as a first step, you can just make a quick Google search and you will know what resistor you need to use. And then if you want to dive deeper, you can decide to learn more about the electrical theory. So for an LED, a pretty standard value is 220 ohm. You will find this value in many different projects. Now, if you don't have 220 ohm resistors, you can use values like 330 ohm or 470 ohm resistors up to, let's say, 1 kilo ohm, which are pretty common too. And if you don't have 10 kilo ohm resistors, you can find another one between 5 kilo ohm and 20 kilo ohm. But if you have any standard resistor kit, this is 99% sure you have the values I'm going to use. And now that you know what values you need for the resistors, the next part is to know what resistor to pick using the resistor color code. As you can see in your resistor set, the value of the resistor is not printed on it. Instead, you get 4 or 5 color bands which you have to interpret. Don't worry, this is not difficult to do at all, and I will give you a few tools that will assure you that you don't make any mistake. First, here is a table showing you what color corresponds to what number and in which order. So usually you'll see either 4 bands or 5 bands in your resistor. In my personal kit, for example, I have 5 bands resistor. If you have a 4 bands resistor, the 2 first bands represent a number. So for example, if this starts with red and red, well, you can see here that the value should be 2, okay, and 2. And here you need to put the 2 numbers together, okay? This is not an addition. This is not, the value is not 2 plus 2, 4. The value will be 22, okay? 2 and 2 together makes 22. The third band, so the third band will be here because you don't have this band for a 4-band resistor. So the third band will be the multiplier. So if you have a band, let's say brown, then you take your first number, which is 22, and you multiply it by 10. So this becomes 220 ohm. And the fourth band is the tolerance, basically how much the real value can deviate from the one you have read. You will usually see brown, gold, or silver for respectively 1%, 5%, and 10% tolerance. Actually, you don't really need to care about this last band. Most of the circuits you will make don't need precise resistor values. And if you have a 5-band resistor, then you don't take 2 bands to make the first number, but you take 3 bands. So if you have 2, 2, and 2, let's say you have red, red, and red, then you have 222. And then if you have a multiplier, let's say brown, so you will have 222 times 10, which make 2,220 ohm. And then the tolerance. So here are the values we are going to use. So first, 220 ohm. So for a 4-band resistor, this will be red, red, and brown. Okay, 22 times 10. And for a 5-band resistor, you will get red, red, and then black. Okay, because black is 0. So 220. And in this case, you don't need to add any multiplier. So the multiplier will be 1. Okay. 1 like here in black. So red, red, black, and black. And then the tolerance. And for 10 kilo ohm, if you have a 4-band resistor, this will be first brown and black to make 10. And then you choose orange, okay, orange, which is 1000 ohm or 1 kilo ohm. And for a 5-band resistor, well, you first choose 1, 0, and 0, so you always choose the number that will correspond to the beginning of the number of the resistance value you want. So this will be 100, and now you just need to multiply 100 by 100 to get 10,000. So brown, black, black, and red. And if you want a quick tool to easily find what is the value for any resistor you have, well, simply you can go on Google and search for resistor color code, and here I have put DGK. So you can type this on Google and then you will see the resistor color code calculator on DGK website. And here you can easily find what is the value of the resistor you have. So let's say you have a band which is red, and then you have brown, and the tolerance, we don't really care about it. And you will see that you have a 220 ohm resistor. Okay, so you have the 4 bands and the 5 bands. So for 5 bands, we have red, and then it will be black, and then it will be black, and we still get the 220 ohm resistor. Alright, and now you can see that for any color you have, you will find the values. So for example, 330 or 470 here, like this. Okay, so you can get any value for 4 bands and 5 bands resistor. And lastly, if you go back to Tinkercad, so the simulation, here on the right, on the components, you can find resistors. So if you don't see the resistor, you simply search here, and then you can put a resistor here. So I'm going to do this to make it rotate. I'm going to put 2 actually. Okay, and so when you have the resistor here, you can put any value you want and choose the multiplier here. So let's say I'm going to put ohm, and I'm going to put 220 ohm. And you can see here we have red, and brown, which is exactly what we have computed before. For this one, let's keep kilo ohm, let's put 10 kilo ohm, and you have brown, black, and orange. Okay, so on Tinkercad you will only have 4 bands resistor, but this is, as you can see, another way of finding what should be the color of any resistor you want. Alright, now you're all set with resistors, and with all the tools you have now, finding the correct resistor from the value should not be a problem for you anymore.